Absolute value. Let's define it. The distance a value is from 0. Absolute value is the distance a value is from 0. If I give you the number 8, the absolute value is 8. It's 8 spaces from 0. If I give you the number -8, the absolute value is 8. It's 8 spaces from 0. There are two absolute values that have the same solution. We get into this point of thinking like, oh yeah, it's just the positive of the answer, right? It's just the positive of it. That's one way of thinking of it. However, we're going to be applying absolute value, so it looks a little bit different. It's just distance from 0. It's distance from 0. Distance can be neither positive or negative. It's just distance. Doesn't have a positive or negative value. It's the distance from 0. We've got a lot of extra things happening. Can we stop? So the absolute value of 10 is 10 because it's 10 spaces from 0. And the absolute value of -10 is 10. There are two values that have the same absolute value. So if I say the absolute value of x equals 8, there are two values that I can substitute for x. What can I replace x with? I could say x equals 8, because the absolute value of 8 is 8. Or x equals -8. Now, when it's nice and simple like this, lots of people write x equals plus or minus 8. We do that for square roots also. This is an acceptable answer. This is an acceptable answer. With both of them. Does that make sense? Do you have to put both? Yes. Because there are two avenues of getting the answer. There are two solutions to this problem. Normal problems, we just find what x is and move on. There's one solution. This time there are two solutions because there's a positive value and then there's the negative value. They will not always be opposites, though, when we get into more complex problems. Really easy problems, they're opposites. What you ask, how you solve these problems, is you ask yourself, what can I replace x with to make the statement true? My problem up here said the absolute value of x is 8. What can I replace x with to make it true? I can replace it with 8, or I can replace it with -8. Both are true. Can I put it in 10? No. It follows the same pattern of solving. It's all follows the same. The goal is always to isolate. Not usually, the end result is isolate the variable. Get x all alone, right? But before I can do that, lots of times I have to do things like I have to distribute, or can I combine like terms? We treat absolute value brackets like they're grouping symbols. So we're going to isolate the absolute value. Sometimes that means I get rid of a coefficient first. I divide. Sometimes that means I subtract something first. But the goal is to get the absolute value all on its own on one side. So if I give you this problem, I'm going to go big with our example. 10 minus 4. And then the absolute value of 5 plus x equals negative 26. Now, before you panic, it's red. 10 minus 4 times the absolute value of 5 plus x equals negative 26. So what I want to do first is isolate the absolute value. So I want this by itself. So there are two things I have to move away, correct? I have to move away the 10, and I have to move away the minus 4. Yes? The first thing I'm going to do is I'm going to subtract 10. I can't move the 4 yet because this is my constant, the plus or minus number. What's getting added or subtracted to my absolute value. I get negative 4, and the absolute value of 5 plus x plus 5, equals negative 36. I want to isolate my absolute value. Is my absolute value alone yet? No. So I'm going to divide by negative 4. The absolute value of 5 plus x equals 9. Is my absolute value isolated? Yes, the absolute value is alone. There's nothing else with the absolute value. Is there stuff inside of it? Yes. But everything else outside of it is gone. It's isolated. Isolate the absolute value. Now, something is going to have the absolute value of 9. Yes? This is going to have the absolute value of 9. I'm going to solve the, I guess, let's say inside for positive. And then I'm going to solve it for negative. Because whatever's inside here is going to have an absolute value of 9. I want x plus 5 to have an absolute value of 9. And there are two ways to get an absolute value of 9. I can either put in positive 9, or I can put in negative 9, because both will result in an answer of 9. So what's this missing x value? 4. Because 5 plus 4 is 9. What's this one? Nope. Because if I put 4 in for x, 5 plus 4 is 9. And what's the absolute value of 9? 9. If I put negative 14 in for x, what's 5 plus negative 14? Negative 9. And what's the absolute value of negative 9? 9. They're not always going to be the same. You have to solve it twice. There are 2 ways of getting an absolute value of 9. 5 plus 4 and 5 plus negative 14. Both result in an absolute value of 9. It gets more familiar as you practice. Example 1. We'll start out a little bit more simple. I want the absolute value to be 12. Is my absolute value isolated? Yes. There's nothing added or subtracted to it. It is isolated. So now I solve twice. Inside of here, I can put the number 12, and it will be the absolute value of 12. Agree? So I'm going to do x minus 8 equals 12. I can also take this out and put in negative 12, because the absolute value of negative 12 is 12. So I'm going to do x minus 8 equals negative 12. I'm going to solve the inside guts of the absolute value for the positive and for the negative. Plus 8, plus 8. The first answer, the first possible solution is 20. And then I check it. 20 minus 8 is 12, which has an absolute value of 12. Or negative 4. And then I check it. Negative 4 minus 8 is negative 12. And the absolute value of negative 12 is 12. So these are my 2 solutions. I have 2 ways of getting this answer. I could have 20, or I could have negative 4. Example 2. 7 plus 2 times the absolute value of 3 plus 2k equals 25. Seven plus 2 times the absolute value of 3 plus 2k equals 25. Can I do 7 plus 2 right now? No. Because this 2 is being multiplied. I can't do 7 plus 2. Because that 2 is being multiplied. That 2 is the coefficient, that 7 is the constant. So let's isolate. Minus 7, 2 times 3 plus 2k equals 18. Then I divide by 2. And I'm left with the absolute value of 3 plus 2k equals 9. Is my absolute value isolated? Yes. Now my absolute value does not have a coefficient, does not have a constant. It's all alone. I know whatever goes inside these absolute values has two choices. I could put the number 9 where my finger is and have an absolute value of 9. Or I could put negative 9 where my finger is and have it be the absolute value of 9. So I take whatever is underneath my finger and I set it equal to 9. And I set it equal to negative 9. So I'm going to take whatever's inside and I'm going to do 3 plus 2k equals 9. And I'm going to do 3 plus 2k equals negative 9. Because those are my two solutions that I can put in here to have an absolute value of 9. Minus 3, 2k equals 6. So k equals 3. With me so far? Here, minus 3, 2k equals negative 12. So k is negative 6. Those are my two solutions. There are two answers to this inequality or this absolute value. I could say k is 3. 3 plus 6 is 9. Or I could say 3 minus 12 is negative 9, which has an answer of 9. You have to solve it twice. What about this one? I'm throwing you a curveball. Two times the absolute value of x minus 10 plus 4 equals negative 20. Step 1, isolate the absolute value. Is it isolated? No. What do I move first? The plus 4. So I minus 4, minus 4. 2 times the absolute value of x minus 10 equals negative 24. Is it isolated yet? Divide by 2. X minus 10 is negative 12. Stop. Thank you. I'm going to tell you right now, this problem has no solution. And I want you to think about it. Think about what each one of these have looked like when we've solved. And what's different about this one. Miles P., what do you think? It's a negative. This is asking me, what can I put right here? What can I put inside this that gives me a negative 12 as my absolute value? You can't have something fit here that results in a negative 12 absolute value. Because absolute value is neither positive nor negative, it's the distance from 0. And this implies that I have time traveled 12 spaces backwards. Now, if there was a negative 1 right here, would that be a different story? because you'd divide by the negative and it would turn positive. But if the absolute value equals a negative number, it's no solution. Can you have negative inside? Yes. But you cannot result in the absolute value of something being a negative value because time travel does not exist. Yeah. All right, one more to get that out of your system because it's not going to happen all the time. Up here. Make it work. Turn it, put it on the other page if you've got room on the other page, or if you've got room up here. Hold, please. I screwed this up already. 7 minus 2. Seven minus 2 times the absolute value of 9x minus 4 equals negative 35. 7 minus 2 times the absolute value of 9x minus 4 equals negative 35. Isolate the absolute value. Minus 7 first. Negative 2 times 9x minus 4 is negative 42. Divide by negative 2, divide by negative 2. The absolute value of 9x minus 4 equals positive 21. This is doable because my coefficient was negative. If my coefficient had remained positive 2, like I screwed up and wrote the first time, we'd say no solution. Because you have to have a positive value here to solve an absolute value. Lots of you at this point will get to the point where you're like, I can do this in my calculator. 9x minus 4 equals 21. So you in your calculator start with 21 plus 4 divided by 9. You got to do 21 plus 4 first. Then divide by 9. It's 25 over 9. Could you put the decimal version of it? Sure. But fraction number value is easier to write. And then you go back and you do for negative 21. And you say negative 21 plus 4 is 17. No, negative 17. Divide by 9. I'm going to leave it negative 17 over 9. Could you put the decimal version of it? Sure.